Hey guys, Mrs. Flanagan here. Today we are going to talk about compound probability. Let's first review the simple probability we talked about in our last lesson. The math department is sitting around eating lunch. There are 8 Chick-fil-A sandwiches, 6 packs of chicken strips, and 6 packs of chicken nuggets. If Mr. Scott pulls out some lunch at random, what is the probability that he chooses a Chick-fil-A sandwich? Remember that the simple probability we talked about last time is when we count the number of elements in A, which A is the specific event we want to know about. And in this case, we want to know the Chick-fil-A sandwich, the probability that he pulls out a Chick-fil-A sandwich. So that is, how many Chick-fil-A sandwiches are there? 8. There are 8 Chick-fil-A sandwiches, and so 8 is on the numerator. And then on the denominator, we put the number of elements total. So that's, in this case, the total number of lunch items. So we need to count the 8 Chick-fil-A sandwiches, the 6 packs of chicken strips, and the 6 packs of chicken nuggets. So that's 8 plus 6 plus 6, which is 20. So there are 20 total lunch items. And 8/20ths can be simplified to 2/5. And then remember that you can also write your probability as a decimal, or you can write your probability as a percent. And remember that for a percent, you just have to multiply the decimal by 100 to get percent. And yes, I do want you to write the fraction and the decimal and the percent each time you find your probability. Now let's talk about compound probability. So this one was simple probability because it's just one thing, one event. But now we're talking about multiple things happening. So that's compound probability. And this is referring to the or questions. If we know the probability of each event occurring, we can add the probabilities together and then subtract items that occur in both groups. That's what this formula means. The probability of one event or another event happening means we can add the probability of the first event to the probability of the second event, but we have to take out the intersection. We have to take out the and. So let's do an example using this compound probability. A school has 857 seniors. There are 19 seniors on the football team, 24 seniors on the baseball team, and 4 play on both teams. If a senior is chosen from the student body at random, what's the probability we select a senior who plays football or baseball? So our probability that we want to find is the probability of football or baseball, which using this formula means we find the probability of football first, we add it to the probability of baseball second, but then you have to subtract out the probability of both football and baseball. So let's look at the probability of football. Let's see, 19 on the football team, and there are 857 seniors. So that is the total we are using, which means the 857 goes on the denominator. And there are 19 playing football. We add that to the number that are playing baseball. So 24 are playing baseball. And so that's 24 out of the 857 seniors. But then we have to subtract out the seniors that are on both the football and baseball team. And that is 4 that play on both teams. So we have to subtract out the 4 that are on both teams. And so when we type that into our calculator, we end up getting 39 out of 857, or as a decimal, that is 0.0455, or as a percent, remember we times the decimal by 100 to get percent, that is 4.55%. Caitlin is selling Girl Scout cookies. She took orders from 26 people. There were 15 that ordered Thin Mint cookies, 21 that ordered Samoas, and 11 that ordered both. If we selected a customer at random, what's the probability they ordered Thin Mints or Samoas? So the probability of Thin Mints or Samoas means we need to find the probability of Thin Mints, add it to the probability of Samoas, and subtract out the probability of both Thin Mints and Samoas. So let's look at Thin Mints. Let's see, there are 15 that ordered Thin Mints. So that is 15 out of how many total? She took orders from 26 people. So 26 people is the total. So that's on the denominator. And then we need to add that to the probability of Samoas. So 21 that ordered Samoas out of the 26 total. And then we need to subtract the probability of ordering both Thin Mints and Samoas. So that is 11 that ordered both. So we have to subtract out 11 out of 26. So typing that into our calculator, we end up getting 25/26, or writing it as a decimal, that is 0.962, or writing it as a percent, that is 96.2%. A six-sided die is rolled. Find the probability of rolling a 3 or a 5. So the die is being rolled just one time, and the probability of rolling a 3 or rolling a 5 means we find the probability of rolling a 3 first. So there are 6 sides on a die, on a dice, right? And so the 6 is the total that we are going to use for the denominator. And there's only one number 3. So the probability of rolling a 3 is 1 out of 6. And then we're going to add that to the probability of rolling a 5. And there's only one 5 on a die, so that can only happen 1 out of 6 times. And then we have to subtract out the probability of rolling a 3 and a 5. Well, since we only have one die and we're only rolling it one time, there is no way to roll a 3 and a 5 at the exact same time. So that's 0 out of 6 times. Adding those together gives us 2/6, which is 1/3, and 1/3 as a decimal is 0.333, or if we multiply that by 100, we get 33.3%. Try this example on your own, then come back to check your answer. Go ahead and pause the video now. All right, there are four kings, so that probability is 4 out of 52. There are 13 diamonds, so that probability is 13 out of 52. And there's one king and a diamond card, so 1 out of 52. And these are the different answers. All right, so we talked about or probability. So either this or that happening. Now let's talk about and probability. That means this and that happening at the exact same time. And this is the formula for and. The probability of A is being multiplied by the probability of B. And there's two different scenarios with the and. One is without replacement, so you don't put the item back, which means the denominator, when you're figuring out your probability for the total on the denominator, does change. And then with replacement means you put the item back, and so the denominator does not change. With this example, we're talking about a bowl that contains different amounts of different colored beads. And when we count all of these beads together, we find that the total beads we have in this bowl are 29. We are replacing each bead after we draw it, and so that's with replacement, so the denominator does not change. And we want to find the probability of drawing a blue bead, a white bead, and then another blue bead. So the probability of blue, let's see, there are 10 blue beads. So that's 10 out of 29. And we are multiplying that by the white beads. There are 7 white beads, so 7 out of 29. And we multiply that by the probability of blue again. And so there is still the 10 because we put the blue back in. We drew a blue out, but then we put it back in the bag. So that's still 10, and there are still 29 beads in the bag. And after typing that into our calculator, we end up with 700 out of 24,389, which is equal to 0.0287, or as a percent, 2.87%. All right, our last example on this page is the same bag, the same bowl, I mean, with the same number of red beads, the same number of blue beads, and the same number of white beads. So there's still 29 beads total. But this time, we aren't going to replace the bead after we draw. We're going to keep the bead out of the bowl. So that's called without replacement. We're not replacing the bead, so the denominator will change. The probability of blue is 10 out of the 29 total beads that are in the bowl. So we draw out a blue, but we don't put the blue back. The blue is gone. So now there's only 28 beads in the bowl. And we want to know how many white beads there are. And there are 7 white beads. And then we don't put that bead back, which means there are now 27 beads in the bowl. And again, we want a blue bead. So the first time we drew out a blue bead. So there were 10 blue beads, but we drew one of the blue beads out and we didn't put it back in the bowl. So now there's only 9 blue beads. And after multiplying that in our calculator, we get 5 out of 174, or as a decimal, 0.0287, or 2.87%. All right, I want you to try example 8 and 9 on your own. Go ahead and pause the video now. All right, because this one is with replacement, our denominator stays the same. If you draw out one of the coins from the piggy bank, you're going to put the coin back into the piggy bank, so there always stays 32 coins in the piggy bank. But now with this one, it's without replacement, meaning once you draw a coin out of the piggy bank, you don't put it back in the piggy bank. And so the amount of coins in the piggy bank changes, right? You start with 32 coins, you draw one out, you don't put it back in, so now you have 31 coins in the bank. You draw another coin, you don't put it back in, so now you have 30 coins left in the piggy bank. So your denominator changes without replacement when you don't put it back in. And our last one is also without replacement. So we start with 52 cards in our deck, and 12 of those cards are face cards. And once we draw one of the face cards, we don't put it back in the deck. So now there's 11 face cards and 51 total cards. And so this is the probability of that happening.